This video is a demonstration of the Share4Land toolbox in a joint use case. The location of this use case is Musanze in Rwanda. In this use case, the Land Administration Office wants to update their land tenure records. They use 4 tools of the Share4Land toolbox. The UAV author generator is a tool for creating author mosaics from photos captured by unmanned aerial vehicles. The second tool, the boundary delineator, is a tool for interactive delineation of visible boundaries from remote sensing imagery. Smart Schema is a tool for land tenure documentation using hand-drawn sketch maps. All of them are run via a common user interface on the Publish and Share platform. It is a cloud-based platform for land administration workflows, which provides services to host and disseminate land administration-related tools and workflows using concepts grounded in LADM. This use case demonstrates how you can update land tenure records for residential and agricultural parcels from orthophoto image using the boundary delineator and Smart Schema. The Land Administration Office collects data in 2 ways. On the one side, it collects orthophotos from UAVs, and on the other side, it collects land tenure information via community mapping. In the community mapping, people draw land parcels on top of orthophotos and indicate the land tenure information. I will now continue demoing the use case on the Publish and Share platform. Here you see the Publish and Share portal. The portal provides information on how to use the GeoCloud services provided by Publish and Share in a land administration system environment. In the demo area, you can find all of our projects and you have access to the tools. On the left side, you see a list of our projects that were produced in the Share4Land projects. Our use case is mapping parcels in Ruhengeri, Clip 3, Rwanda. On the right side, you see a map and you can zoom to the project area. To open the project, you click here. In the Project Info tab, you find general information such as the project name and the project description. In the Resources tab, you find all resources that are used by the tools, such as author images and sketch maps. In the Output tab, you see the list of output files that are produced by our tools. The resource and output elements are based on LADM concepts, like spatial sources or spatial units. The Tool tab brings you to the 3 tools that were produced in the Share4Land project: the Author Image Generator, the Boundary Delineator, and Smart Schema. I will now start the demonstration with the UAV Author Generator. The UAV Author Generator is based on OpenDroneMap, a state-of-the-art open-source image processing application. The tool uses modern photogrammetry and structure from motion to generate 3D point clouds, digital surface models, and author mosaics of UAV imagery. The input that this tool uses is this raw aerial data image archive on Publish and Share. To run the tool, you click on Tools, UAV Author Generator. To start the operation, several parameters need to be specified from the drop-down menu. The flight configurations and aerial extent of the UAV mission determine parameters such as image overlap, context of the scene, and mode of georeferencing. In contrast, the image scale for reconstruction as well as the resolution can be modified according to the expected quality of the output orthophoto or surface model. A click on the Start button initiates the photogrammetric processing. Due to the large amount of data, this is a time-consuming process and might take up to several hours. I prepared the output for you, the orthophoto, which you find in the Resource tab because it is the input for the next tools. The next tool I will demo is the Boundary Delineator. The Boundary Delineator is an external tool using the application development interface of Publish and Share. It combines functionalities implemented in MATLAB, Python, and QGIS and can be accessed as a QGIS plugin. This tool helps a user to delineate visible cadastral boundaries from a UAV ortho image in an easy way with less clicking and in less time. To open this tool, you have to open QGIS. You can load the data from Publish and Share by clicking on the Share4Land project button. After connecting to Publish and Share, you see the current list of projects. We select our project and then we can load the ortho image as base layer and load the image segmentation lines as segments layer. After processing the data, you can see the vertices where two green lines meet. And you can see the simplified segments. The dark green lines are the original lines and the light green lines are the simplified segments. To delineate boundaries, we go to step 2. There are different functions for delineating boundaries. In the polygon function, you select lines and the outline of these lines are connected to a polygon. Other functions are the line function, where you select lines for an area which is not closed and it will be auto-closed. The vertices function, which connects two selected vertices along green lines. Or functions for manual delineation. You click the Accept button to store the final boundaries and upload the data to Publish and Share. You can see the output of the Boundary Delineator in the Output tab in Publish and Share. The next tool is Smart Schema. Smart Schema allows the user to use hand-drawn sketch maps as sources of spatial data for mapping land rights. The tool extracts the boundary contours of drawn geographic features and allows the user to align the features to a georeferenced base map. Input sketch maps can be freehand sketches or sketches drawn on top of the aerial images. Tenure land right information can be added to each drawn feature and saved in the Publish and Share platform. With Smart Schema, you can speed up the process of digitization of hand-drawn sketches in participatory mapping. Furthermore, Smart Schema enables you to use local rights, restrictions, and responsibilities via the local domain model. To illustrate how the process works, we have a small video. First, the participant marks the reference points on his drawing on a transparent sheet on top of the orthophoto. Afterwards, he draws the parcel boundaries. Once he has finished drawing all parcel boundaries, he labels the parcels and the reference points. To digitize this information, you can remove the transparent sheet and scan it. This is the input sketch map for Smart Schema, which you can also find on Publish and Share in the Resources tab. The land tenure information are specified in discussions with the communities and note it down for each parcel that is drawn in the sketch. To open Smart Schema, you click on Tools, Smart Schema, Start. Smart Schema will start in a separate browser. You can start the process by loading the data from the Publish and Share platform. On the left side you see the sketch, and on the right side you see the author photo. The first step is to vectorize the image. Click Vectorize, Automatic Vectorization. All polygons in the image are detected. When you click on Align to Geometry, Smart Schema uses the reference points in the sketch and projects it into the reference system of the author photo. Now you can annotate the land tenure information for each polygon. By hovering on top of the polygons, you can see the alignment. To annotate the land tenure records, you use the right mouse click and it will open our domain ontology. First, you need to select the party owning the land parcel. And then you can specify the rights, responsibilities and restrictions for this parcel. For example, there can be an agreement that the owner has the right to lease this parcel, or the owner has the restriction that he cannot subdivide the parcel. You have to annotate the land tenure information for every parcel drawn in the sketch. You can now query the land tenure information by clicking on any of the parcels. Through the alignment, it is automatically connected to the georeference spatial unit on top of the author photo. After having saved all land tenure information in Smart Schema, you can save it as an admin source document to publish and share. Now the data is saved to publish and share, and you can see the output in the Output tab. Here are the boundary phase strings from the Boundary Delineator, and here you can see the spatial units from Smart Schema. You can visualize them in the map on the right side. The bluish lines are the boundary phase strings from the Boundary Delineator. The advantage of the Boundary Delineator is that it gives you precise geometries because it is digitized directly from the author photo. The Smart Schema polygons come from community mapping, and because they are hand-drawn, the geometries are less precise. But they include potentially not visible information, such as this boundary here. This information is only available to the local people and can be collected only via community mapping. Furthermore, it contains the admin source documents for each parcel. Here are the spatial units listed, and to look at the admin source documents, you click on Highlight and it will show you the admin source documents that were stored in Smart Schema. So as you can see, the output of all three tools are integrated in Publish and Share. It can be directly accessed via the user interface or via an API for further processing. A next step, for example, could be merging the land tenure information from Smart Schema with the precise boundaries from the Boundary Delineator to register spatial units in a land administration system. If you're interested in further information, please visit our It's4Land website.